Welcome back to the channel. I know you're excited to be here. I'm excited to have you here. Like and subscribe. We're going to do number 5. F of x is 2, x plus 4 squared minus 1. Well, where is that coming from? It's coming from a parent function, and that parent function is y equals x squared. So let's make a table for y equals x squared that shows the values that go with it. Because any function is just a relationship between two variables, x and y. For example, when x is negative 2, y would be 4, because that's negative 2 squared. When x is negative 1, y would be 1, 0, 0, 1, 1, 2, 4. And that creates this parabola that we all know and love, y equals x squared. Okay. So it looks something like that. All right? But that's not what it asks us to graph, so I'll just take that whole thing away. But that's what the function y equals x squared looks like. And that's the parent function. That's where all other quadratics come from. So f of x is a quadratic, and it comes from y equals x squared. It's just a transformation. And we know that there are aspects of this function that transform f of x in a certain way, a, h, and k. A is your vertical stretches and squishes, stretches and compressions. H moves it left and right. It's a horizontal shift. And you know that when it's with your x, it's kind of weird. It's going to go in the opposite direction. And K shifts things up and down. All right, so our A value is 2. K value is negative 1. H, remember, it's weird. It's opposite. It's negative 4. Okay, and that's because the formula already has x minus built into it. So if you have minus a negative 4, that's where you get that plus sign. And what do we do with those numbers? Well, we multiply let's start over. To get our new x's, okay, x squared has been moved to a new location. To find its new location, the x values, we will add h to them. In this case, that means taking away 4. So we get negative 6, negative 5, negative 4, negative 3, and negative 2. All right, and the way we get our new y values is to start with the old y values. We multiply by 2, and then subtract 1. Multiply by a, then add k. Multiply by a, then add k. Multiply by a, then add k. And you get 7, 1, negative 1, 1, 7. So we can graph this new function, negative 6, 7, negative 5, 1, negative 4, negative 1. And there are ways to graph that without doing the table. I recognize that. And if you recognize that, I want you to recognize that you are doing the table, you're just doing it without writing it. Okay, so we're all using the table somehow, even if we're not writing things down. And that's how we get f of x. Well, how do we get g of x? G of x is a transformation of f of x. Okay. It has its own a, h, and k values. And we need to know what those a, h, and k values are so that we can apply the transformation to these points. Okay, we're transforming points. A is 2, h is, you're right, it's 3, and k is 1. So to get new x values from these old f of x's x values, we're going to add h to them. That means plus 3. Add h, and we get negative 3, negative 2, negative 1, 0, 1. And then to go from f of x's y values to g of x's y values, we're going to multiply by a, add k. Multiply by a, add k. Multiply by a, add k. And I'm going to stop right there, and I'll show you why. Negative 2. This is a plus sign. So that gives negative 1, 3, 15. Because this is quadratic, you'll notice that on either side of the vertex, it's always a mirror image. Okay? And so once I get to the vertex, which I know is right here, then it's going to be the same on either side. So now I just graph those points. So negative 3, 15. Whoa, that's way up there. Can't even do that. Negative 2, 3. Negative 1, negative 1. 0, 3, and then 1, 15, which is way up there. Okay, so this is a, holy cow, that's a bad line. It's hard, people. You do it. Been taught. Also from here. We have a super tall quadratic function. It gets tall very fast. And it has been stretched, so it got stretched, and then it also was shifted over and down. No, and up. All right, so that is f of x. No, that's g of x. Thanks for watching. Okay. If you're still here, kudos. We're going to do composition now. So if that's what you came for, here comes the composition of that function. And I have so many regrets now. I wanted to leave that, but it'll be okay. All right. Number 5. We're going to do this by composition now. And f of x is still going to be the same. Start at negative 4, negative 1. And then instead of going over 1 and up 1, we have to double that because a is 2. So we're going to go up 2. And then instead of going over 1 and up 3, we have to double that. We're going to go up 1, 2, 3, 4, 5, 6. So that would be right here. Man, that's so hard. It's the hardest thing I've ever done. Maybe not, but close. All right, so time to do g of x. How in the world do we do g of x? We can do it through composition. 2. And we are composing because we have to place f of x's equation inside of this to get g of x. Okay, so g of x has f of x inside of it, like the Holy Spirit, but with quadratic functions. So nothing like the Holy Spirit. All right, so f of x minus 3. You can tell I'm delirious, I'm sorry. F of x minus 3 is inside g of x's function. Well, we have to know what f of x minus 3 is. So what is f of x minus 3? Well, to put it simply, it is f of x's function, but instead of having an x, we put x minus 3 in for the variable. So when we come to this x right here, we're not going to put x, we're going to put x minus 3. I'll do that down here. X minus 3 plus 4. Squared minus 1. Okay, so look, nothing different about f of x except instead of putting an x right here, I put x minus 3. And now let's simplify a little bit. Okay. So here is f of x minus 3. Okay. So up here in g of x's equation, when I come to f of x minus 3, I'm going to place that whole function right there. 2x plus 1 squared minus 1. And the plus 1 still comes down here at the end. So now I'm going to simplify a little bit. I have to distribute this 2. I'm going to multiply it in there and get 4x plus 1 squared. And then 2 times negative 1 is negative 2. This plus 1 comes down. G of x is equal to 4x plus 1 squared minus 1. Now, this is g of x. That is the actual function g of x, which we didn't even find when we used the tables. We just found its points. Now we have the actual function that is g of x, which means we don't need f of x anymore. We have placed it inside g of x and simplified so that now we have a function we can transform just like we did f of x's function. So h, k, that's our vertex, negative 1, negative 1. Remember where it was earlier? If you watched it, go back to the first 5 minutes and see where g of x was. And then we have a stretch of 4. So when we go over 1, instead of going up 1, we're going to go up 4 times as much to right there. Then when we go over 1 more, instead of going up 3, we're going to go up 4 times as much, but we go up 12 to 15, which is way up here. and that is the same that we had earlier. So it's super tall, super fast. It has been stretched, moved left one, and down one, and that's g of x. All right, that's it. Have a good day. See you tomorrow.